So this video is to talk about the equal sign, which is without doubt the single most used symbol in all of mathematics, but is probably one of the least discussed. It's just sort of assumed that everybody understands what it is and they will use it liberally within their work. And I would argue that it is actually slightly misunderstood in a way that can make progress difficult. Now, the type of student misconception that we see in school, I'll just put up some examples now, and then I'll talk about how I think the equal sign should be viewed and understood. So the type of work that we don't want to see is things such as this: 5 plus 7. We quite often will see this sort of work. Now, I can understand why the student will do this, because in their head it makes sense, and they would be reading it to themselves as, we have 5, we add on 7 and that makes 12. We then add on 10 and that gets us to 22. We add on another 5 and then we end up with 27. And they will use the equal sign and apply words and language to it as though it's just an and, a runner on, a joiner of different pieces of thinking. But we'll come back to it in more detail, but what this is actually saying mathematically is that 5 plus 7 is the same value as 27, which it absolutely is not. Okay. Now it's one thing just to tell students don't do it. We also need to put in place what the equal sign means and allow them to build up a picture of better thinking. Now, another example of questions that we want to talk about, and this is a genuine question from testing in Australia and New Zealand. Was this question here. And according to the research, approximately 1/2 of all the year 8 students in New Zealand and Australia couldn't answer this question correctly. Now, it's interesting to know what were the incorrect answers. We know that the answer should be 14, but a large number of students put this down as 18. Because they simply read 10 plus 8, and the answer is 18, and they left it. Again, they didn't have that understanding of the equal sign. It wasn't they couldn't add or take away values or do calculations, it was actually misreading what that symbol means. Another incorrect answer was 8, because 8 is the same as 8. And again, not seeing the entire piece of mathematics, and again, not understanding what the equal sign means. And another one, which is my own personal favourite, was 5. Now, the reason for this one is that the students, you can imagine, have been in lots of classes where they've been told, look for patterns, see the similarity, look for symmetry, and they've gone, 1/2 of 8 is 4, so 1/2 of 10 is 5. And it just makes sense to them that there's this pattern that they're trying to identify. And again, it's actually quite subtle thinking, but it is mathematically completely incorrect. Now, on the poster, I've put up a large number of values, very common descriptions of the equal sign that I'm going to ask people to try and gently eradicate from their classroom. The answer is makes equal to, you end up with, and one that I'm aware is a little bit controversial at the moment, balanced with. I will discuss that in a moment. Balanced with is controversial because it's running all the way through the new curriculum. I actually disagree with its use, and I hope I'm going to be able to persuade you in this video why I don't think it should be used as a phrase. Now, I'm also going to explain why I'm holding this stick. So this stick is something that I use in my teaching a lot. And the way I work it, and if you could just imagine I'm in front of a class of students, is I'll simply ask them to say, what are they looking at? And the first answer they'll say is a stick. And my response is absolutely correct. You're thinking like a mathematician, just describe exactly what's in front of you. So then the conversation will go something like, it's a stick that's balancing. Cool. why is it balancing? Because it's the same. Okay, how is it the same? Why is it the same? Eventually the students will get to the idea that the weight on one side is the same on the other side. So the weight is identical here and here. So I'll say, okay, so the stick is exactly the same here as it is here. And then they'll go, no, but you just told me it is the same. And this is the first time that I'm getting them to explicitly discuss the idea that the weight is the same, but the appearance is different. Now this is a physical example, but the stick is the same in one sense and not the same in another sense. And I then explain to them that this is actually the true job of the equal sign. It takes two pieces of maths where the entirety of one side of the equal sign is exactly the same value as the entirety of the other side of the equal sign. But the appearance of the left and the right sides can and will often be completely different. And this is the thing. So if I was to look at this one in here in red, I would say on the left, the value of the left side is 18, and the value of the right side is 18. So the left side is the same value as the right side, and that is actually the phrase I think is most useful. Balanced with, you can see why they're talking about balance, but it's only one of those parts of it. And I think it's the least important. It's the value that is actually what we're talking about. Balance can be confusing, the student said. They don't actually see the idea of balance as a phrase to describe what's happening as being connected to the value of the left and the right hand side, and they get confused. And I've often seen students that will talk about balance, and we're trying to do algebra in year 11 and year 12, and they're unaware of the language connection, the whole complete concept they're trying to work with. So we're talking about two pieces of maths, different in appearance, but the value is the same. And we can make some changes. If I change colour, if I made this but we can make some changes. So imagine I had this. I've changed my statement that was in red to one that's in blue. But my left side is still the value of 18. And this is completely unchanged in terms of value and appearance, and this is still 18. It's still true, but it's not the same appearance. So I've changed the appearance, but I haven't changed the value of anything. But I am capable of changing it again. So far as now to say, how have I changed my red statement to my green one? I've changed the value of everything. By changing the value of everything, I have also changed the appearance of everything. So you can change the appearance and not the value, and we might call that rearranging in algebra. Or I can change the value and the appearance. But the whole key is that it is using this idea of the two sides being always in the same value to each other. And any changes that I make, whether they're to value of appearance, have to maintain that balance. So the balance is part of it, but I would argue that using balance as the description of what's going on doesn't give the student the full picture. The same value as is what's important. So if we talk about things like the answer is, or equal to, or you end up with, or makes, they have a place in terms of the students are intuitively looking at the work and making sense of it. But it doesn't help them because it creates this idea of the maths having a narrative that runs in a certain direction. So, a number of students will tell me that that's been written the wrong way around. Because as far as they're concerned, maths has to have a question and the answer is whatever that value happens to be. Whereas in fact we should have a left side and a right side where they are the same value as each other. And later on, if you look at the multiplication ideas, this becomes incredibly helpful when we start looking at multiplication being a rectangular shape. So the area of a rectangle is the same value as the two sides being multiplied together, just as the two sides of a rectangle being multiplied together is the same value as the area. One is no more the answer in the question than the other, which is a way of viewing the maths that is essential in Year 11 and beyond when we start dealing in algebraic thinking and high-level mathematics.